This is a quick report on the arcade keyboard which I've built, which works on PC, Nintendo Switch and PlayStation 3. The specs for this keyboard is that it is a 60% keyboard with Cherry MX red switches using a Brook Pi PCB. The keycaps are OEM for the WASD keys and the rest of them are DSA. The button configuration is shown here. I went for a configuration such that the L2 and the R2 button can be accessible by 2 thumbs and the Start, Select, Home buttons are out of the way. I chose the RGB to be magenta to match the artwork of the keyboard. If you spot any mistakes or have any suggestions, please leave them in the comments so that people viewing the video could see the comments as well. The important parts I need are the 60% keyboard case, which I bought as plastic, and also the 60% keyboard plate, which I chose to be aluminium. I've also bought Cherry MX red switches, and also the keycaps shown here, and the Brook's Fighting Board 0 Pi version. The first step I did was to solder on wires onto the switches using a soldering iron and solder so that it wields the wires onto the switches. Then next I could screw in the wires using the screw terminals, but I also need to solder in the R3 and L3 buttons. And then before I proceeded any further, I tested the keyboard on a game called Tiger on the Nintendo Switch. The PCB should be held on by the wires underneath the keyboard plate. I've got screw-in stabilizers as shown at the bottom for the larger keycaps at the bottom of my keyboard. Stabilizers are there to help the MX switches to be activated when the keycap is pressed on the far edges. Unfortunately, these stabilizers require a keyboard PCB to be screwed into. Thus I use Mulli-Put, which is a epoxy putty, which is our 2 parts as shown here. What you do is you take a bit of the putty and mix them together to form some sort of putty which is quite sticky. Then I use this putty to mould the stabilizers onto the plate, and then you can see here that the stabilizers are quite solid stuck on to the plate, and with a bit of testing it sounds really good. Next is the final way to attach the keyboard plate onto the case. I measured the holes on the keyboard plate to be 4mm in diameter, therefore I went for M3 screws. This is something called a hex connector, which is something a screw can screw into. What I did was I removed some of the stands off on the keyboard case using a Dremel and moulded the hex connectors onto the existing stands off on the keyboard case using Mulli-Put, and hopefully everything lines up so that the screws can screw into the connectors, attaching the plate onto the case. I wanted something low profile, thus I didn't use the USB-B terminal for this project. This piece here is called a Japanese solderless terminal type XH. This can plug directly onto the PCB, and each pin of the terminal is labelled here. So I need to solder each of the 4 wires, or each 4 pins, to the corresponding 4 wires of a USB cable. I use heat shrink to protect the wires, and this could plug directly onto the PCB. For the RGB strip, I got a Rgb Strip which is powered by USB. I've cut off the USB connector, which exposes 2 wires, a red wire for 5 volts and a black wire for ground. This can plug directly onto the Brook Fighting PCB. Then carefully I wrapped the Rgb strip around the keyboard plate and stuck it on using duct tape and electrical tape. I got a 2mm thick acrylic and cut it to the shapes of the keycaps on my keyboard. For the artwork, use with permission by any, I printed the artwork on 170 grams per square meter paper with a silk finish and cut it to size. And then everything could be put together, but it is quite a tight squeeze inside this little tiny keyboard case. But once it's all done, everything should work quite nicely with the switches or keycaps lit up quite nicely. One of the hardest things of this project was how low profile the keyboard is going to be, especially when I'm using stiff wires. So at the moment I'm using 5 amp wires and trying to squeeze in Rgb strips into the little keyboard, and then you got some large components like the screw terminals and the USB-B terminal, which adds a bit of height onto the PCB, which is quite difficult to squeeze all of those things inside a keyboard case like that. This could be improved if I use thinner wires rather than 5 amp wires, and also I should try and consider desoldering some of the larger components from the PCB. You can see that the holes of the connectors, the keyboard plate, the artwork and the acrylic sheet don't line up exactly. You can see this by the screws, they're not exactly perpendicular to the case. The problem with the mulli-put moulding the stabilizers onto the plate is that the mulli-put doesn't look so good on the side. Perhaps there may be stabilizers which connect onto the plate. For Linux, I've provided a bash script here which enables the controller to be recognized as an Xbox controller on Linux. Make sure you're looking after your soldering iron. On the left is a completely burnt tip which now can't be used anymore. And lastly, I haven't looked into lubing my MX switches, which is something I haven't considered but recommended to a lot of keyboard enthusiasts. Thank you for watching. I just hope that this video will help someone down the line, perhaps building something similar as I did here. Thank you.